Break it down. Everybody join, it's a party. To this beat, give me an naughty. Stand up and shake your body. Let me see you dance it all off entirely. Everybody join, it's a party. To this beat, give me an naughty. Stand up and shake your body. Let me see you dance it all off entirely. Display your work on the dance below. Get jiggy like you never done before. So good, so I gotta let you know. Roll along in the name. I'm a simple girl with a stable background and family. I don't want you fancy me for crazy, freaky stuff. Since came to things, I'm just trying to keep it real, baby. Oh, I wanna, and I'm gonna touch the sky with this music. I will make you fly, keeping you high. Oh, I wanna, and I'm gonna touch the sky with this.
Well, I want to thank the school for making it possible for school to have mathematics laboratory. In fact, these materials will help the teachers to drive home their points. All of them are important. There are so many, they have so many. This shape now, showing network. This is a cuboid. It's showing all the network. Then this one is a cone. You see the network and it's closed. So by the time they get the formula for calculating all this, they will not only cram them, they will see them, touch them, feel them, then derive the formula by themselves. With that, they can record the formula, put in the exam, and solve all their problems. This is showing radiation from the sun, and all these are orbiting. They are orbiting round. There are some mathematics they can learn with this. During this locus, they can use this to calculate locus. But when some people say, they say it's only by geography. It's not only geography. You can use it to calculate different radii. You use it to calculate the locus. For calculating the speed of wind. They should keep it up and set pace. They have started setting the pace, let them set more by purchasing more things. And teachers will try and put them into use, because getting the materials by the school authority and they are packed somewhere, teachers are not making use of them, is not what we encourage. We encourage the teachers to reciprocate the gesture of the school by putting them into practice. Thank you very much. We've seen the fantastic laboratory, math laboratory. Because we have seen the math lab, we are confident that a teacher from the school should handle a topic on the geometry set. They will use it, the teacher will use it to teach a topic he has prepared. And the teacher is not represented by myself. Okay, please handle your class. Let us just watch you teach any topic we have prepared using the geometry set. Thank you.
Now, as we did in the class, we have done trigonometrical ratio. And again, we have done sine and cosine rule. Now, remember what I told you? From our definition, we have defined geometry, geotrigmetric, as you will see from here, geotrigmetric, and you have your own on top of your lockers. Geotrigmetric, we have defined trig ratio as something that has something to do with 3. And geo is the measurement of lines, angles, and shapes, different shapes. That is what geo means. Now, to confirm what we did in our previous class with this geotrigmetric, to confirm our class. So this thing now we enhance the work with this. We don't need 4-figure table or calculator anymore. With this we are covered. But notwithstanding, after getting our answer here, we can still make use of four-figure table to confirm it. Exactly. The angles between 0 degree to 360 degrees. We said that the trig ratio of any angle is the acute angle which the radius must define with x-axis. Now in that class, we drew a plane circle, divided into 4, which we call quadrant. From here now we have 0 degree or 360 degree. Here is 90 degree, 180 degree, 270 degree. Now, as we are now using this quadrant, we confirm it with geotrigmetric. Is that it? Yes. Now, remember from this quadrant, quadrant means to divide into 4 equal parts. We have divided into 4 equal parts. Each of these is called the quadrant. We take this one as the first quadrant. This one is the second quadrant. This one is the third quadrant. This one is the fourth quadrant. ST, to remember the quadrant. Cast. If we go anti-clockwise, it will give us cast. If we go clockwise, it will give us acts of the apostle. Now, the reason why I'm referring us to this quadrant is just to tell you the relationship, is to bring the relationship between this quadrant and the geotrigmetric. Now, in the quadrant, as I said before, that the trig ratio, geometrical ratio of any angle, is the acute angle which the radius must define with x-axis. With our geotrigmetric, now from your own, you will put this one of the meter ruler constant at 90 degrees. Remember, trig ratio has something to do with a right angle triangle. Only in a right angle triangle. A right angle triangle is a triangle which put one of the ruler constant at 90 degrees. Just straight at 90 degrees. Find sine 45, cosine 45, and tan 45. It will be at 90 steady. Do you see it? It will be at 90. Then the other ruler, the second ruler, you put it at 45 degrees. Then one will be at 90. The other one, you will shift to 45 because we are now trying to find the trig ratios of 45 degrees. The trig ratios are sine, cosine, and the tangent. Now do your own now. This angle is 45 degrees. Is that clear? Yes. Now sine 45 is what? Now here, knowing that this is a right angle triangle, these two rulers now has formed a right angle triangle, isn't it? Now, at sine 45, we give us opposite over hypotenuse. Sine is opposite over hypotenuse. That is the definition of sine. Now what I want you to do now is to read from your ruler the length. Exactly, and not from the 4-figure table. You read. Now, read now. Opposite of this 45 is from this point to this end. Read from your meter rule. Read from your meter rule. What do you have? Very good. Which means 5 cm. We now write 5. This side. The side facing the right angle. The side opposite the right angle. See the right angle here? Read this from your meter rule. 7. Which means we have 5 over 7. See it here. 7 divide 5. Cannot we put point at 0? 7 divide 50 will give us 7. 7 times 7, 49. 50 minus 49 will give us 1. 7 divide 1 cannot, we add 0. 7 divide 10 will give us 1. 1 times 7 is 7. 10 minus 7 will give us 3. 7 divide 3 cannot, we add 0. 7 divide 30 will give us 4. 4 times 7, 28. 30 minus 28 will give us 2. 7 divide 2 cannot, we add 0. 7 divide 20 is 2. 2 times 7, 14. Remember, 6. 7 divide 6 cannot, we add 0. 7 divide 60, 8. 8 times 7, 56. Knowing that this is a recurring decimal, so we can stop at 5 decimal places to approximate. Exactly, the normal approximation is 4 decimal places. Exactly. Yes. So what we now have is this 0.71428. When we approximate it to 4 decimal places, we have 0.7143. Now, this is what sine 45 gives us an approximate answer. Now, let us confirm it from our 4-figure table. Turn to your 4-figure table, sine of angles in degree. Sine of angle in degree. Anyone who sees it will read for us. Sine of angles in degree, sine 45. 45 under 0. 0.7071. Then from table now, our answer from table. See it. This is our answer from Geotrigmetric. Is that clear? Yes. This is our answer from our 4-figure table. It is almost the same thing. If we are asked to approximate this answer now to 1 decimal place, to one decimal place, it will give us exactly the same. Isn't it? Yes. This one will give us 0.7. This one will give us 0.7. Is that clear? Yes. Now, if we are asked to approximate to 2 decimal places, this one will give us 0.71. This one is 0.71. The same thing. Is that clear? Yes. So now, whether we use 4-figure table or we use our geotrigmetric set, it will give us an approximate answer. Almost the same. Is that clear? Yes. Now, let us take another angle at the second quadrant, knowing that the first angle we pick, which is 45, is from the first quadrant. Is that clear? Yes. Now, who will give us just one angle between 90 and 180? One angle between 90 and 180. 120. Here is 120 degree. Sine 120 degree, knowing that we are using right angled triangle. And in a right angled triangle is a triangle which one of the angle is 90 degree. Is that clear? Yes. Now, we have to reduce this 120 to acute angle. From our definition, we said that the trig ratio of any angle is the acute angle which the radius must define with x-axis. Now let us bring this 120 degree to an acute angle. Now sine 120 will give us sine 180 minus 60, isn't it? Yes. 180 minus 60 will give us 120. Therefore, sine 60 degree. We now go to our geotrigmetric. Now, this ruler will be constant. Shift this one to 60 degree. Shift only this to 60 degree. Now, sine 60 degree, knowing that as you shift this meter rule to 60 degree, this angle is 60 now, which is the given angle. Which is now the given angle. Sine 60 will give us opposite over hypotenuse. You get me?
Yes.
8.5.
8.5.
Sine is opposite over hypotenuse. Read from here. What do you have from here? The hypotenuse side. What do you have from here? 15 minus 8, 7. So we have 74. Add 0. 98 divided 740 will give us 7. And 7 times 98 will give us 6. 6 what? 686. Remember what? 13 minus 8 is 5. We add 0 again. 98 divided 540 will give us what? 5. So we can now approximate our answer, which will give us, we got 0.88775. Approximate to 4 decimal place 0.88778. Now, let us go to our 4-figure table to check our answer.
0.8660.
8660. Which is an approximate answer to this. Is that clear? It gives us an approximate answer to this. If we are asked now to approximate our answer to one decimal place, we have 0.9, 0.9. We have done sine 45, sine 120. Let us look at cosine 45 degree. Adjacent over hypotenuse. Now, change your angle to 45 degree. Cosine 45 will give us what? Adjacent over hypotenuse. 5, very good. 5 over 7. Knowing that sine of any angle is the cosine of its complement. Is that clear? Yes. Or the cosine of any angle is the sine of its complement. It will give us the same thing. Sine 45 is same thing as cosine 45. Sine 1 degree is same thing as cosine 89 degree. Because 1 plus 89 will give us 90. They are complement angles. Is that clear? Yes. Now, let us leave the meter like that. Tan 45. Tan 45. Tan is what? Opposite over adjacent. Now, opposite is what? Read from your geotrigmetric. 5. Then, tan 45. 5 over. Then, adjacent. 5. Very good. 5 divided 5 will give us 1. Now, go to your 4-figure table. Let us confirm our answer. Exactly the same thing. Is that clear? Now, knowing this, having known this, with the work of geotrigmetric, we can find our answer very, very fast. Is that clear? Yes. Which means, with your four-figure table or calculator, once you get into the exam hall with your geotrigmetric set, you are covered. You don't need calculator because sometimes your calculator may fail. But with this, you are covered. Nothing like wrong answer. Are you following? Yes. Now, let's take another angle. Now, let's look at cosine 120. Cosine 120, we want to bring it down to acute angle. 180 minus 60. So cos 60 now. Change your angle now to 60 degree. To 60 degree. What you need to do is just to change only. I said that this one will be constant at 90 degrees. Just be shifting this. Cos is adjacent over hypotenuse. Adjacent is what? 5. Isn't it? Then 5. Hypotenuse side. 9.8. So we can now divide. Now, if you want to remove, assuming if you want to use long division, if you want to remove this decimal point, multiply both numerator and denominator by 10. So that this decimal point will go. We now say times 10 over times 10. 10 times, 5 times 10 will give us 50. 9.8 times 10 will give us 98. We can now divide. 98 divide 50. 98 divide 50 cannot. We put 1 as 0. 98 divide 500 will give us what? Is it 5? Yes, let's try 5. 5 times 8 is 40. Right 0 carry 4. 5 times 9 is 45 plus 4. 49. Very good. Remember? 10. Now 98 divide 10 cannot. We add 0. 98 divide 100 is 1. 1 times 98, 98. 100 minus 98, 2. 98 divide 2, cannot. We add 0. 98 divide 20, cannot. If you add 0 here, you now add 0 here. Is that clear? Yes. 98 divide 200, 2. 2 times 8 is 16, carry 1. 2 times 9, 18 plus 1, 19. Remember? 4. 98 divide 4, cannot. We add 0. 98 divide 40, cannot. If we add 0 here, we now add 0. 98 divide 400, 4. So 4. So it will now give us approximately to 4 decimal places. We have 0.5102. Now, let us again check our answer. Confirm our answer from the four-figure table. 0.5002. Okay, 000. Now, 5.0000 is our answer, the result from the table. Now, we got this one from our Geotrigmetric, 0.5102. Now, assuming if we are asked to approximate this to one decimal place, you will notice that we got the same thing, exactly the same thing. 0.5, isn't it? Yes. Now, sine and cosine rule. Is that clear? Yes. Now, remember from our definition, trigonometrical ratio has something to do with right angle triangle. Whenever you talk of a right angle triangle, the method you will apply is trig ratio, isn't it? Yes. Now, sine and cosine rule is different from this sine, cosine, and tangent we use here. Is that clear? Yes. Now, let us apply the use of sine and cosine rule using geotrigmetric. We can solve triangles, no matter the type of triangles, apart from right angle triangle. if 3 sides of a triangle are given to us, with all the angles unknown, we don't know any of the angle, we apply cosine rule. Now, if again, 2 sides with included angle, with only one angle, included angles are angles which are formed in between the 2 given sides. We call it included angle. We can equally apply cosine rule there in such a case. Now, where are we to apply sine rule? We can apply sine rule whenever 2 angles and any of the sides are given to us. We can equally apply sine rule whenever 2 sides with one angle opposite any of the sides, with one angle facing any of the sides. That is the 2 cases where we can apply sine rule. Now, let us do the practical work. We can use any angle. See what? 40 degrees, which means this angle will give us 30. This one is 40 degrees. 30 plus 40, 70. Therefore, this angle now is 70 degrees. Now, let me draw it on the board. So here we have 70 degrees. We can label it A, the triangle ABC. Is that clear? Yes. Now, the side facing angle A can be called small a. The side facing angle C can be called small c. The side facing angle B can be called small b. Now, let us read the sides. Read from here, from this point to this point. How many cm? From this point to this point. From this meter rule to this meter rule. 3. Now, here is 7.3 cm. 3 cm. Here, this meter rule from here to this end. From this end to this end. Read. 6.9 cm. So here is 6 side. Read the other side. Read this side. What do you have? What do you have this side? 7.6. The formula for sine rule. A over A equal to sine B over small b equal to sine C over small c. Or we can say small a over sine A, which is equal to small b over sine B, equal to small c over sine C. Any of these can give us what we want. Now, since we know angle A and the side facing angle A, we now use it. Small a is what? 7.3. Then sine A is what? 70 degrees. Equal to, if I are now asked to find angle B, we now use small b. Small b is what? 7.5 over sine B. So we are now looking for sine B, which we don't know. We are now from our Geotrigmetric. We are looking for this angle because this end is our B. So we are looking for angle B. Is that clear? Yes. Now 7.3 over sine 70 degrees. Punch it out from your fourth table. Sine 70 degrees.
0.9397.
99.
9397.
37.
9397.
0.9397.
Then equal to 7.5 over sine B. We cross multiply. 7.3 times sine B will give us 7.3 sine B. Equal to 7.5 times 0.9397. Which means sine B is equal to 7.5 times 0.9397. 9397 over 7.3.